Okay, we'll get back to the meeting. And I need the slides back on here, so.
Yeah. And I don't know where you want it. Here we go.
Is it being shared? Is it being shared?
No, it's not.
Let's
Almost put a pussycat after the next slide. So what's up?
Okay, Michelle Boyce is doing what's new.
Test. Wait,
All that?
change my slide?
No,
Okay.
I thought she wanted yours up.
Yeah.
Testing. Yeah, it never works. Okay, is that working? Yeah,
Here you go.
working. That's working for me. Alrighty, so I'm doing what's new today, and I'm going to talk about Euclid. It's actually kind of funny. It's Euclid just had images for the first time, and I'm like, it's Euclid. And that happened this week, so I did some digging. There's a lot of stuff going on. It's hard to keep up with things. So wait, which laptop is the one
On your left, yeah.
arrow key doesn't work? Okay. Oh, God. Okay. So Euclid, well, I'm calling it First Light. I'm sure it was earlier, but they released the images this week on the 7th. It's interesting. Euclid has really crisp, spectacular images, but it's not really for that. In a way, it's what they want to do is make a nice detailed 3D map of the universe to understand more about dark matter and dark energy. So what I figured I would do is talk a bit about the satellite, its capabilities, and mention a bit about dark matter, dark energy as I go along. And then at the end, I'll show you some of the images I got. They're pretty cool. So it's launched July 2023, and the first images were released this week, which is when I heard about it. Okay, so anyway, this is the Elon's Musk vehicle. What's it called? Oh, there it is. SpaceX Falcon 9 rocket. Yeah. Okay. So for those that like to do astrophotography, well, I don't think you're going to get your hands on this baby, but it's a 6 million pixel camera, 0.5 square degrees of sky area, which basically is 3 times the surface area of the moon. That's how big a swath of sky it does. Its resolution is 0.1 arc seconds, and the great red spot of Jupiter is 8 arc seconds across, just to get some perspective. There's 2 instruments. This is called the VIS instrument, and it just means visual instrument. And you can see here, I just put the visible light spectrum so you can get an idea. It's from 500 to 900 nanometers. If you don't want to think in nanometers, which is 1 billionth of a meter, just look at the visible spectrum here, and that gives you a sense of the colors of light that correspond to those numbers. Okay. And this is an early commissioning test of it, and you can see all these ganged pixel pads that it's testing out. So this is the visual instrument. So let's talk about dark matter. What is dark matter? This is just one of my generic slides from courses that I teach. I try to remove any math, but basically, dark matter could be anything that you can't see to some particle we've never heard of. So for instance, if you have a star and there's something you can't see that passes in front of a star, then you'll get a change in the peak of the star, and that'll tell you that there's something there. So it's a massive object and it bends the light around it, okay? So if you think of space-time as a rubber sheet, there's a mass there, light goes around and it gets bent around. So examples of brown dwarfs, white dwarfs, black holes. This is a Gaia survey of machos, and every winking light you see there is an event that they found. And you can see the years moving at the bottom. And so these are like objects like black holes and stuff. And the point here is that statistically, this does not make up for the amount of dark matter that we see in the universe, which basically tells us that it's probably some kind of particle that just doesn't interact with light. It only interacts gravitationally. That's just a more general picture. So from Euclid's not looking at our galaxy in particular. It's looking way out at all the galaxies and stuff. So you may see cluster galaxies like this, and then these little arcs. And what that means is there's a large mass and there's a galaxy behind there or something with light's being bent around. And this is called gravitational lensing. The other one I showed you was weak gravitational lensing. So if you want to make a gravitational lens analog, just break off the bottom of a wine glass, slide it around on a piece of paper, and you'll see how it distorts things. This is the NISP instrument. Basically, it's measures spectroscopic redshift. And it also takes images. It also has a camera with the same resolution as the visual camera. And it's in this 900 to over 950 nanometer range. It's in here. It's in the infrared. We can't see in the infrared. If I show you an infrared picture, it's because they mapped all the colors to your visual eye. So this is just a bit of a slide to tell you what redshift is. You know, when you look at a Bunsen burner or whatever with a prism, you can see a spectrum or spectrum from the sun. Well, the universe, if you think about the universe as a bubble, like a surface of a balloon, and you draw little galaxies on, you start blowing, that shows sort of inflation. So it's a 2D model. And what's happening is when you're looking at a star or a galaxy that's far away, the light gets stretched, or the spectrum shifts into the infrared. So it becomes more red the further you look back in time or across the surface of the balloon. So by looking at the shift in the spectrum, you can tell how far away an object is and how fast it's moving away. And that's referred to as redshift, and it obeys Hubble's law. And that is the reason why it's in the infrared. It's because these frequencies are shifted out of the visible. So this is the early commissioning of the NISP instrument. So you can see the high resolution, and each one of those pixels will have a certain spectrum to it, from which they can then determine what's called a photometric redshift, where they're looking at the little individual pixels to try and gauge the distances. Whoops. Dark energy. What can I say about dark energy? We absolutely know nothing about dark energy, but we do have theories and stuff, and Einstein's theory of general relativity, cosmological constant, yada, yada, yada. But the bottom line is we really don't know. We have a better grasp on dark matter, which we don't know, but at least we have a better sense of it. So this has something to do with vacuum energy and so forth, and really is probably tied into quantum gravity, which are theories we don't actually have testable models for. And why is there dark energy? Well, basically, we thought that, imagine the universe has a certain amount of energy put into it, it expands, and not enough, then it either collapses back on itself, or it has enough energy that it just keeps slowly going. Well, we did not expect this when we started measuring things. We did not expect the universe to be accelerating. So it's the analogy is, here's the Big Bang. It starts growing and it's like the dark energy is like a spring, and as the universe gets bigger, it starts to accelerate out. And the important thing to note here is, look at this here. In the early universe, the universe is about 14 billion years old. Our sun is about 4.5 billion years old, to give you some perspective. Here's the dark matter. Here, 60%. And all we see here is 15% of visible matter. And in fact, at our current date, only about, it's a sliver, it's about 5% or so that we see. But now notice the amount of dark energy that's, well, my cursor's not really, anyway, yeah. Now notice how the amount of dark energy is growing as the universe starts rapidly accelerating. So the idea of Euclid is that it's this and this images together will provide a high resolution map of the universe. So here, this is an old Sloan digital sky survey. Each one of these points is like a galaxy, and we are here. Okay, and this is the distance away. This is the redshift. So the redshift is basically the shift in frequency into the red. How much the frequency is shifted, the more it's shifted, the further away it is on our balloon. So when we have a better understanding of that, we can model. So this, if you look at this, this is a model of the large scale structure of our universe. The way I like to think of it, you know, when you wash your dishes and you see all that soap, right? Well, the soap kind of represents the dark matter, and where the lines meet is where you start to get galaxies to form. Okay, especially at nodes. So you can see this soap bubble-like structure that's happening. Okay, the more detail we know about that, the better we can model the universe and understand the properties of dark matter and dark energy. This just shows basically how Euclid does its scanning. And also, yeah, it was with James Webb when I became a presentation of James Webb, I became obsessed with halo orbits. And I finally found something on Wikipedia. I mean, I had to dig through papers, and then finally I found something that verified it. But basically, let's go to this diagram. These are Lagrange points. If you take the sun and the Earth is doing this. Now imagine that you take, imagine that you're standing in that line at the end. Well, you're being pulled in by both, but if you're orbiting with both, there's a stationary point where you won't fall in. It's almost like taking a rock on a string and doing this. Okay. There's also another point in between the two where the gravitational thing is equal. And so here in this you see L1, L2. And what's also interesting, so this is the Earth, and this is the Sun-Earth L2. So that's the stationary point, the Lagrange point 2. And Euclid is then doing this three-dimensional lasso-like orbit around here. This is with respect to the Earth moving around in the orbit of the Sun system. And I think it's pretty cool. You can also make Lissinger figures. But the main purpose of that, so James Webb lives out here, Gaia lives out here, and now Euclid. And the main purpose of that is that with the halo orbit, it was proposed initially for a moon mission for going on the dark side of the moon. For halo orbit, you always have constant communication with the Earth because you're going around like this and the moon's in the middle. And for James Webb and so forth, you have complete 24-hour access to the sun because you're orbiting like this, clear away from the Earth's shadow. Anyway, it's a fascinating piece of dynamics. Okay, so let's look at some pictures. So there's just a couple of pictures. This is the Perseid cluster, which is about 240 million light years away, taken by Euclid. These were released this week. This is Spiral Galaxy IC 342. Actually, I was reading up on that. Interesting thing about that is hiding behind is like hiding behind dust in the disk of our galaxy. So infrared punches through dust. You're actually looking behind dust clouds, so you wouldn't normally see this. And then here's again, a regular galaxy. Regular, you can sort of see a bar shape in there, but and this is NGC 6822, 1.6 million light years from Earth. Closer to home, 1,300 light years away is the Horsehead Nebula. It's such a beautiful picture, especially if you look online. This doesn't give it much justice, but it's really nice. And a globular cluster 7,800 light years away. And so this is just the summary slide of the science of Euclid. So the idea of Euclid is to get a more highly detailed 3D map of the galaxies in our universe back to about 10 billion years to help us better understand dark matter and dark energy. So it will constrain models. The more detail we know, the more constrained it will be. So that's it. Any questions? Nope.
Thanks, Michelle. I know we saw the announcement and the pictures online from the Euclid, and it's just stunning. I agree that the picture of the Horsehead is just fabulous. So now it's my pleasure to introduce to you, if you don't know him, Richard Conrad, or Dr. Richard Conrad, as I understand, who's a classical musician, born in Winnipeg, has a family, a couple of children, and he's made a living performing as a concert pianist, not only in North America, but in England. And he had originally studied at the University of Western Ontario, and then Banff Centre School of Fine Arts, Royal College of Music in London, in England, Webster University in St. Louis, and finally at Indiana University, where he received his doctoral degree. And interestingly, astronomy has been his hobby all along, right from an early age. And then it was rekindled when he had children, and they started to look up and they started to enjoy things together. He originally, or not originally, but he did have a 20-inch Dob, and he's explaining in the hall. It wasn't really what he was after, and he wanted to do astrophotography, started to do some of that, and then found that there was a conflict, not with the cold, he didn't say anyway, but with having imaging at night and having a life in the daytime. And a number of people in many fields have this issue. So he has chosen to go to remote observing. And with that, I'm going to hand this over to Richard and look forward very much to his talk on remote observing.
Thank you. Do I clip this on?
Yeah, you can clip that on your collar,
Okay, got it.
somewhere around your glasses.
Hey,
And you can put this in your pocket. And are we shared? You have to share on the other.
Oh, yeah, yeah. He just needs to share his screen. In theory.
I'm gonna share screen right here.
Yeah.
Okay, I'm gonna share that. And
Here we go. Okay,
looking good.
I think you're good.
Okay. I'm good. Okay, hello all. The sound quality is a little muffly, so I'm going to speak up a little bit, but let me know while I'm talking if I'm overdoing it or underdoing it. Just put your hand up and say I can't hear you, or okay. All right. Well, anyway, thanks, Judy, for introducing me. Now that was my introduction, so now I don't have an introduction to give you. That's fine. Yeah, it's remote imaging. It's this, well, just astrophotography in general. I just absolutely love it. And there was a lot of frustration involved when I was doing it the usual normal way. Part of it was that it required me to stay up all night, and Kim has insomnia. It's better if I'm with her at night. So that's kind of what's shaped my astrophotography. And I guess going back just a wee bit, I had a 12-inch, and then I bought a 20-inch Daub, and I had big mechanical problems with it. I got it on a great deal. I was really excited. But it got to be so frustrating. At the point, I even bought a special trailer for it, and I put all kind of cushions around it so that when I went over railroad tracks, it wouldn't break the mirror. But I didn't consider the sideways motion, so I actually did get a crack in the mirror after all that. Anyway, I end up selling it to Jerry, and with the proceeds, I decided to buy a tracker. I've got a Celestron AVX. And my imaging equipment is a Canon 600D SLR with a 300 millimeter zoom lens, and no guiding at all. And I found it so fiddly, and I rarely got any kind of result that I could work with. That I finally threw my hands up in the air and did some research. And then I asked Kim for Christmas gifts, so 160 points towards iTelescope. So the 160 points is 160 US dollars, and I was quite excited. However, I did discover, and that was the membership price for 1 month. I soon discovered that this is very unsustainable. It's a lot of money. And I figured that I would knock off, half a dozen targets just like that. But in the remote imaging systems around the world, you have to remember that the scopes are being used like all the time. And so there's also a lot of downtime. There's a lot of maintenance that needs to be done on these. And so you lose your scope that you started with. So you got to wait till next month or whatever. So anyway, regarding iTelescope, they have also offered a cheaper alternative, which I'm using, and I'll get into that just a little bit later. So I'm not all that knowledgeable about all the variety of telescope company systems around the world. I kind of settled with iTelescope, and it's working for me. I know a little bit about some of them. Telescope Live is a very, very popular one. I think a lot of notable astrophotographers use their systems. Nick Semanek, for instance, does that. Adam Block uses the Schulmar 32-inch from Mount Lemmon, Arizona. And anyway, there are a lot of well-known astrophotographers that just do remote imaging. Deep Sky West is another one, based, I think, in New Mexico. They have roughly 7 scopes, and they work things a little bit differently. So for a subscription, you choose one of their 7 scopes. So that could be 135 millimeter Samyang camera lens, or it could be a 20-inch. And there's sort of a set price for that. For the smaller systems, that'd be $600. For the big ones, $3,200. And basically, you form a group depending on telescope that you put your name down for, and democratically work out the targets. And then the staff image for you. So it's very much hands-off, this particular system, but the data you get is absolutely incredible. You can actually give you some free data just to just to wet your lips, just to see if you can be interested. So you can go down there and download some data. But I know some of them are, 40 hours worth of imaging. iTelescope, again, which I use, it's in contrast because you have full control over everything. You have control over exposure, which filters you want to use, specific coordinates. And in the end, you still have to stack your light frames from the FTP server. But they calibrate them for you, so you don't have to worry about any of that. Another firm that I found is called SkyGem, and they're based in Nairobi, and they've developed amazingly within a couple of years. When I imaged with them, they only had 2 scopes, and now they have 25 all across the world. And so it's similar to iTelescope in the sense that you have full control. But the only difference here is that when you submit your plan, all of what you want to do for your shot, the computer puts you in a queue and then decides when the light conditions are best. So it's a little less hands-on in that sense. But anyway, I thought I would just show you a few pictures, websites, just to give you a feeling of what kind of scopes you would be using and the prices. Okay. So what's clear? Okay. Yeah, so this is iTelescope, and they've got 2 pages, one called Affordable and another one called Premium. That's all a matter of definition. But so we're ranging from a camera lens, a 135 camera lens, to a 24-inch plane wave located in California. So here is just an example of some prices here. This is the cheapest one, $26. But as we get moving to the 20-inch, etc., you're going to get up a little higher, $50. And the ones, so the ones in Chile, they are the most expensive. Happens to be my favorite skies to view, to photograph. So here we get $83. This is per hour, and that's US. So yeah, so it can add up. In contrast, I want to take you to SkyGems. Okay, now these points are in euros, so you just have to multiply that by 1.5, something like that. So you've got something here, yeah, 30 points an hour, 15. I think I saw one somewhere for 8. So these are a lot cheaper, and this is probably where I would go if I wanted to actually book the scope and use it in that way. Okay, so despite the expense of iTelescope, I decided to go with them as they have a few other perks. And here, as a member, any member at any rate, it can be the minimum rate or the maximum rate, you get to use 2 scopes free. So one scope is an 11-inch RASC F2, and that's in Utah, and the other one is a 12.5-inch Ritchie Chrétien in Australia. And you're allowed to use these as members for 30 minutes per day. On demand. So it means that you can't book it. You just have to sit there, look at the whole button, and hopefully you'll get it. And the other perk is during the full moon, when the moon is illuminated by 75% or more, that's for 8 days, you get to use any scope free. So obviously, people are not using their scopes during full moon, so that they're trying to encourage usage. But I've done most of my astrophotography during those 8 days, and I'll show you some examples shortly. So anyway, for the free scope, the free scopes, I tend to do RGB images because I can duck away from the moon. And during the 75% illumination or more, they call that happy hour. I do narrowband imaging because the filters largely cut out the moon illumination. So I pay $25 per month and I get all this imaging. So that's pretty good. Unfortunately, for anyone who wants to join, they've eliminated that plan and now it's 50. So, although I think for 50, it's still a good deal. And again, I'll show you pictures to show you the kind of quality you can get. Yeah, so they grandfathered me the $25. They're very, very nice. Very nice people. They gave me a few extra points when they knew I was doing a presentation here. Okay, so let's show you a few pictures. Okay, do I do this? Oh. I lost my bookmark. Sorry, just give me a second here. Is there any way to get rid of this bar? Does anybody know? That's where my address needs to be. Yeah. Oh, thank you. Okay. Okay, so I use Flickr. Okay. Oh, okay. And oh, okay. Well, that looks washed out. I take such care in getting just the right colors and everything, and then it looks washed out. But anyway, just do the translation in your own head with your eyes.
It looks great on Zoom,
Okay, good.
so you can check it out.
Okay, okay. Okay, so this is M45, and this is an example of the free scope in Utah. It's the 11-inch RASA. And you'll discover later, I actually will mention that you can't change the orientation. Okay, so this is actually a two-pane mosaic of two portrait pictures because I couldn't turn it around to frame the nebula properly. So that's one of the drawbacks. Of course, they do that because of creating calibration frames for you. Okay. This is the three-pane mosaic, again from the same camera. That's the 11-inch RASA. And normally to get this kind of a picture with other telescopes, it would take hours and hours of exposure. But this is literally 1 hour, 3 panes, 1 hour exposure to get this. So the RASA F2 is an incredible light gatherer. This is using the 12.5 Ritchie-Chrétien in Australia. Trifid Nebula, that's starless. Again, this is the free scope in Australia. Sculptor Galaxy. And this is Centaurus A. I'm happy to get a lot of images in the Southern Hemisphere. The targets are just amazing. And that's M33. This is I paid for this one. And this is the Rho Cloud Complex, and I paid for that one too. So this is before I knew of their cheap way. This is the Milot 15, the Heart Nebula. This is just HA, and now I'm taking photos during the full moon. Okay, so the Dragons of Aral taken from Chile. The Statue of Liberty taken from Australia. All in the full moon. This is Eagle Nebula from Chile. M17 from Chile. And North American Nebula from Chile. And the Carina from Australia. And that's from Utah. That's from Chile. That's from Australia. I think it's a 120 refractor. The Running Chicken Nebula. You can't really see the chicken in there, unless you can. And this is also from Chile. This is the M16, M17 environment. And now we have bicolor of North American Nebula. Bicolor of the Tarantula is taken from Australia. And then finally M42 from Utah. So anyway, there may be time when you find you're using a few extra exposures to compensate for the full moon, but I found that it makes very, very little difference. The HA and S2 are better with the full moon. O3, you have to be careful with. Okay. I'm just going to get out of here. Okay, and I drew up a little list here. Pros and cons. F11. Yeah, so the pros. So you get to image the southern hemisphere. You can find a dark sky all over the world rather than being stuck with your conditions locally. No need to mess with calibration frames. This is a little eye telescope specific, by the way. You don't pay for any images you're not satisfied with. Of course, in my situation, that doesn't apply since I'm getting the free moon time. Image with your choice of 25 scopes, ranging from 135 millimeter camera lens to a 24-inch plane wave. And again, keep your costs down to $50 per month. No need to spend time traveling and setting up your equipment. Rather, image from your armchair. No need to stay up all night. And it's especially good if you're lazy. And the cons I mentioned is the orientation. The camera is fixed. You can't change that. And many image systems are often down due to intense usage, especially if you're following one target with one system. You have, oops, sorry. For a while there. And it's costly if you choose to book a scope. I say, although imagine purchasing any of these systems, they're incredibly the Takahashi, it's the top equipment that you could get. Not very social. Agree. Not as fun as to image in the group. And you don't get the feeling I did it all by myself, if that's important to you. Just how far you take that, just realize you didn't create the camera with the scope. But yeah, so imaging tends to have, I don't know, there's a feeling that you're somehow cheating. You know, you're not going to all the effort it takes to set up your scope. Anyway, I don't feel this way, but I do miss the social interaction of getting together with people. Okay, so I'd like to take you to the iTelescope main page, just to show you how I do things. Okay, let's see if I can do this. Okay, so this is called the launch pad for iTelescope, and it's a lot of information here. Here, your account history, everything you've done, how many points you've used, et cetera, et cetera. Links, it will show you booking overview. It'll show you everything, what's been booked. Or it can just show, it can just show your own booking. If you want a shortcut to the telescopes, you can do that here. But I use the Launchpad mainly for information like on this orange-yellow banner here. It basically says what's not working, and it doesn't give you any information as to how long it may take to fix them, but it says what's going on. The main reason I look at this page, though, is to find out what telescopes are available and if there's bad weather. For instance, here, this is in Spain, and roof closed indicates it's cloudy. This is also another system in Spain, cloudy. Okay, and Sierra in California. Now this is available. So I thought what I would do, so I'm not jumping here. Yeah, I'm jumping ahead a little bit. So I'm going to take you to another site. And this works in tandem with iTelescope and with a number of other companies called Telescopius. Some of you might know it. It's basically a planner. It helps you to find out. Am I still going? No. Testing. Should I just try to talk really loud? Okay. Okay. So Telescopius, it's basically a planning website, and it's linked together with like I said, with iTelescope and with other companies. So, for instance, here, let's just say I'm going to want to image. Let's say I want to go to Utah. So there's the Utah Center. Okay, so from this point, I might want to know whether I can image or what the sky conditions are. So just click on the 7-day hourly forecast and it'll give you information here. So tonight, for instance, clouds are excellent, the seeing is excellent, the wind is excellent, and the humidity is good. So that's almost perfect conditions. And if you have an idea when you'd like to image, you can just move this bar. And it shows you basically darkness up here. That's obviously the sunrise. But the darker these bars are together, the better for imaging. Okay, so let's go a step further, and I'm going to find an object, and I'm just going to choose something like M33, let's see. Okay, so the Triangulum Galaxy. Okay, so users have also uploaded their images, so you can look at other people's images if you like. But here it'll show you where the image is highest in the sky. And this is the sunset, and that's sunrise. So basically shows you when it's the best time to image. So you got with this remote telescope imaging system, you have you can use so many different scopes, different targets. You can make sure that you're almost always shooting at zenith. It's incredible. And so here it is, and it's framed it according to the scope T11, which happens to be in Utah. So if we chose another scope, for instance, and I chose see T14 or 20, which is one of the most wide angle refractors they have, then that would show you, it'd be framed something like this. Okay, so I'm going to go back to the launch pad. And I'm going to choose T21. Can't remember what that is. Yeah, it's a 17-inch plane wave. And there's a hold. So I execute that. Okay, so it tells me that I've placed the telescope on hold for 5 minutes. So I have 5 minutes to execute a plan. Now, normally I write these plans in advance and then save them, so I'm not under sort of a time crunch. But I just want to show you how this works. So I'm going to deep sky objects is what you want to click, and this is the plan. So you write out your plan name, which I call M33. Again, target M33. Now you can have the system look up the coordinates for you automatically, which is great for galaxies. But if you're doing a nebula and you want some special framing, or you're doing a mosaic, then you have to put the information into these boxes. But for now, what I'm going to do, whoops, what's going on there? Oh, just my luck. Something's wrong. Okay. So, am I disconnected?
Well, you just have to go back to share your screen.
Okay.
That's all.
Okay.
Figure out what you
Okay, so I'm connecting. I'm going to run out of my 5 minutes, so I think I better keep going. Okay, so I've got to do this a different way now. And this is the way I normally do it anyway, as I'm going to put the coordinates down manually. Oh boy. Yeah.
You have to click on share screen because we can't see anything.
Okay, okay. Yes, it's connecting. So should I go to the email and just start again?
Well, no, you're still in Zoom. Just look up here. Yeah, just down to the share screen.
Yeah.
Okay, because it's not connecting.
Oh,
Yeah.
weird.
Yeah, you don't see it that there. It's not connecting.
Yeah.
Oh. I could continue on there if that makes it, if you want me to do that.
You'd have to know the links, you have to transfer those over.
Oh, okay.
Your browser.
That's always super slow, I think.
Yeah, yeah, probably go
Just
back to
start
the link.
over.
Yeah, if you can go back to the link
Okay.
soon, yeah.
Okay,
You can find that in there somewhere.
I will. Oh. I think we have an internet problem. That's issue. Okay, I can't get to my mail. I can't get this. Okay. Okay, I'm going to probably going to lose my my hold, but that's okay. Okay, so I'm going to go to scope 21, which is the one I put on hold.
We can't see anything on the screen until you get.
Yeah, of course, sorry. Then guest, it's good. Okay, let's go back to
What did you
I
get?
can't even get to my email if you won't let me get to my email now. So they're like Gmail, right?
I don't.
So I don't know if it
links.
well, it's there's not it's super simple.
Mhm.
There's connection and
Is it?
do you want us to see if
See
that's
on-
doing okay?
Yeah, this one I can tell right now is, let's see here, it's doing okay. I'm on Wi-Fi there and it's got
Okay.
internet access.
Okay,
So I just
can we
don't know what,
transfer?
well, you're certainly welcome to use,
Okay,
Chrome on this if you want. Is using Chrome. But you'd have to know the links and all that, like the URL that you're going to. Did you want to try that?
yeah. I'll just do it. Just wait to wait too much longer.
Okay.
Okay, so Gmail.
Okay. Okay.
Okay. Okay, so okay, share screen. This one. Okay. Sorry, this will take a little bit. Oh, just wanted to log into my email.
Oh, if you know the credentials, go ahead. Just type over them.
Yep.
And
Okay.
Yeah.
Okay. Oh. I was worried I might not fill up the time, but Hey. Oh, God, sorry. Okay, okay. Let's try that again. Okay, here we go. Okay, here we go.
You don't need to sign that in the meeting.
Oh,
That was already signed. You can just go to your web browser and go to the items.
Oh, I don't have to do, I'm sorry, I thought I had to reconnect with Zoom.
No, that one is already connected.
Oh, okay,
It's already-
and we're sharing, we're good, so I'll just continue the presentation.
Yeah.
Okay, okay,
Sorry.
okay, so. Going back to the launch pad, see if I can grab another telescope. Yeah. Mhm. Okay. Okay, so we're back here. Yeah, so we'll try T5 from Utah. Okay, put it on hold. Deep sky objects. Now this is where you do your plan. And I'll start over again, M33. Target, M33. And hopefully it will look up this information. It does. And it's automatically entered the coordinates here. And if you wanted to view to see how it was framed, you'd click that, and that would take you automatically to the Telescopius website, which I just showed you. Okay, I choose dither. Mandatory, I think. And I'm going to take clear. That's luminance. I've never heard it termed like that. So let's take 3 pictures. Duration 5 minutes. Now I have a choice to either create the plan for sometime later or execute it now. So I will do that. So I can show you run started successfully. And up here in the system status, you click that, it'll tell you exactly what the telescope is doing. Okay, so it goes through and it'll try to locate a guide star for for guiding. It will focus after so many shots as well. And then you have an option of previewing the image you just took. So it'll be a JPEG stretched version of the one frame. Okay, so I'm going to go. I'm going to go back and just spend a little more time showing you how this works without having to worry that the hold button is going to expire. Oh, sure. There it is. Okay. Okay, so if I just want to do some planning, let's say I'm going to image in Chile. This is actually my favorite scope, 371. So good. It's all right. Let's try that again. Okay, let's just try that. Okay, here we go. Okay, so scope T11, it's a plane wave 20-inch. It's usually faster than this, but okay. Okay, so I want to create a plan for this particular scope. This is also in Utah. And let's just say I wanted to do Horsehead Nebula. B33. Okay, and I want to do my own custom framing here. So where's my telescope? Lost it. Telescope. I'm going to go to Utah. I'm going to type in the Horsehead Nebula. Okay. So that's going to get taken sort of around 252. Okay, and I'm going to need to select the T11 scope. Okay, and so I can frame that any way I like. And let's just say let's say I like that. Okay, so here you can see the coordinates, and it's just a simple matter of clicking this. So copy to click to clipboard. And paste. Similarity. There. Okay, dither. And I think I'd like to do some narrowband with this. So I'll put HA. And let's say 10 minutes. And let's just say whatever, 3. And I'm going to do, oops, what's going on? Okay, so I'm going to do a Hubble palette. So maybe some O3. 10-minute shot. And finally, sulfur 2. And again, a 10-minute shot. Okay, so at this point, I'm going to say create a plan for later. Oops. Oh, sorry. Okay. Plan saved. Okay, so this is what I do, and there's tons of you'll see I've got some plans going with almost every scope, but let's just view my observing plans, and it'll show what plans I've done, and you can view them. Okay, but so what I normally do to execute a plan is I always just go and run a save plan. And there's Horsehead. And then I would hit acquire images, and I'm taking pictures. Is that clear enough? Okay. Okay. Yeah, there's a lot more to say, but that's basically it. I think I'd like to see if we have got a preview here for the T5. Okay, preview last image. Oh, come on. Okay, it hasn't given me that image yet, so we'll just leave that. But it does give you, it gives you a preview so you can see if you're way off, like if it's the focus is off or there's a cloud in the way, then you'll know about it. Okay. So I just, for what I do, I just showed you sort of the classical way of booking a scope, but that's not really what I do. So I would put the scope on hold, but the free scopes are never on hold. They're always being used. So you literally have to, first come, first serve. You have to look at that hold button for a half hour and grab it, and hopefully you got it. So you kind of have to wipe out a half hour of your day, or for that matter, during full moon, where you can use it for a whole hour. Then that takes another hour out of your time. I find I'm 4 out of 5 times I'm successful, but there are many people who are also hoping on that hold button. But the price is so cheap that I'm willing to put up with that. Okay. Okay, I think that's pretty much the end of my presentation. I wish the quality of the pictures you saw were a little bit better, but I'm impressed with what you can do under a full moon. I never knew that, and I wouldn't have known. Probably wouldn't have known if I was continuing to image with my camera only. Anyway, are there any questions, Scott?
So if, say you want to take a picture at a specific time, you're looking at, say, an asteroid that's moving or something like that. Can these systems sort of handle that, or is it?
I forgot to show you the reservation. Yeah, that's major. Make a reservation. Yeah.
Oh, okay, perfect.
Yeah, so that shows you people have booked it, shows when you can do it. It's a popular scope, but here, for instance, so I'm going to do something. Make a new reservation. So you can fine tune the time that you want. Select your plan. There's Horsehead. And confirm. That's it. Yeah. And so here, you really can be very lazy. it just does it for you at that time. Again, if you book a scope, then you pay for it. So that's where the expense happens. During the 75%, sorry, 50% illumination of the moon or more, you get 25% off. So anyway, any other questions? Judy?
Hi, Richard. Richard, can you hear me?
So can you also view on real time when it is imaging, or it's only post processing?
So you're asking me if you can view what your phone?
Right.
No, that's where the preview picture works. So the preview that I was hoping to show you, which maybe I still can. Yeah, there you go. So that would be your preview. Now this, the T5.
Only after 5 minutes, right? You set it up for 5 minutes, then you can view only after 5 minutes, not during when it is taking the picture. What scope is show the saying if we can't see that on real time.
Yeah, if I understood you. Not sure if I fully understand, sorry.
You get the real time, like as it's integrated more and more.
That is, that's something they're working on, live control. Live control, coming soon. So the answer is not yet. Yeah. Okay, so this particular, sorry, where was it? Sorry, I'll almost. This is not my favorite system. You can see there's, what's it called, blooming? Yeah, blooming here. It's a very old camera. And there are ways of processing to get rid of that, but it's a great scope, but the camera is very old. So I generally stay away from T5, but it was available, so.
You're getting fixed files back from the camera, it's like, is that what you get from?
Yeah, the FTP, you set up, there's an FTP server and everything's stored there. Yeah,
Make sure they're all calibrated.
they're already calibrated, but they're individual light frames, so you have to stack them. But they're already calibrated, yeah.
Can you access the calibration information, or it just auto does it, and if the flat was no good, you wind up with?
I think you can. I've never had reason to try, but I think you can. Apparently you can download a bad pixel map if you're using software like Astro Pixel Processor. Yeah, in fact, iTelescope is sort of a promoter of that software, and it also does sort of regular tutorials. So as a member, you can freely do the tutorials.
Are they doing calibration for the same type of like frames, or do they have a library?
I think they have a library. That's why that's why you can't change the orientation. That they've got to have a fixed orientation to know what to do. Yeah.
Hello? Richard?
No. Gee.
Can you have, say, a single membership and then share the login amongst, say, 4 or 5 people? Does anybody? I mean, it's
Oh.
probably not proper.
That's a way of doing it, I guess.
Something like it either, but I think it would be feasible for a group to sort of sit down and say, well, let's take these 10 locations, and then one person could feed all that info in, I guess.
Yeah,
That
yeah.
would be how it would work.
Yeah.
How far in advance do you reserve?
Couple of months. I don't know exactly. Couple of months, maybe. I've gone to the reservation page. You just scroll as far as you can. I'm actually not entirely sure. Yeah, but no, I log in on computer. I'll have my phone logged in at the same time, so I have multiple logins. In fact, I always use my phone to hit that hold button because it's a little quicker. Yeah, and like I say, usually I'm successful, but if you're imaging the Orion Nebula or something, you got a lot of popularity, and that's the toughest time to catch it. Yes. How long? Which?
How long? How long can you use?
It's a half hour per day. Yeah, the free telescopes are a half hour per day. And during the 8 days of full moon, then it's 1 hour for any scope. Yeah, so it takes quite a few days to get an image, but I'm certainly doing a lot more astrophotography than I did before.
Just a quick follow-up. There is a automatic way to set up your browser that you could automatically connect to the platform that's available and go down to the browser.
Oh,
Thing called robotic process automation software
wow.
that basically mimics it knows where all the user interface elements are on the web page.
Oh, wow. Is that like an add-on, like an extension, or?
Usually a standalone program.
Yeah.
But these days you can use Microsoft Power Automate Desktop.
Yeah.
That's on desktop. It's a low code thing. And you basically have to recognize a web page.
Mhm.
To have it tapped on a particular area, like a button. And
Wow.
as soon as it changes, say that, go down and press it,
Oh, that's how those people, few people get ahead of me, because they they got it all automated like that's amazing. Oh my gosh. You can't fight that, I guess. Okay. Any other questions?
Can you hear me, Richard?
Okay, thank you.
Thank you very
Thank you.
Just hang on a sec. Oh, here we are. So Scott gave that nice talk on meteors and meteor showers. Richard? So here's a little token of our thanks for the talk today.
Thank you.
And apologies for whatever snafu happened with the internet, but you recovered really well.
Okay,
Thanks so much.
Thanks.
That's really interesting. Okay, does anybody have anything they'd like to share or say with the group? No?
I have one thing I was discussing with Scott, during the break, for the telescope for kids.
Right?
So next to this monthly meeting, maybe we can plan some fundraising part for the December and January. So maybe we can have more discussion and share with the members.
That sounds good to me. I mean, I know fundraising is dear to a couple of people's hearts in the room, and a lot of people have some really good ideas. As I said, we are trying to find a chair of that fundraising committee to help us launch it. We have kind of terms of reference for the committee drafted, and it's kind of getting ready to go. I think about a smaller project, and maybe telescopes for kids is a good place to start since it is happening. Good idea. Thanks, Kamala. So if there's no, Wing? Oh, right. That's the third Thursday. Okay, Thursday, November 16th is Astronomy Night at Oakhammock Marsh, and I know Jerry and Sylvia often go out there, but I know they also appreciate additional volunteers, and I think if you show up with a telescope or some viewing apparatus, you get free admission. Okay, thanks, Wing. Yes, Damon?
Just let everybody know, we got an outreach request for probably January with the Wildlife Side program. We'll probably start looking or soliciting volunteers, probably starting the next month's meeting. But just giving you back your minds that we are still doing outreach. We could have some looking probably for the new year.
Right, so I'm not sure if the Zoom people heard that, but I'll repeat it. So there is Wild Outside program through the, I think it's Canadian Wildlife Federation, has a youth program, and they contacted us, and we're setting something up for January so that people can see the moon in the daytime before dark, and then see some of the objects in the sky at that time. We'll be recruiting volunteers for that at the next meeting or two. Okay. So if there's nothing else, I'll call the meeting adjourned, and some of us welcome to proceed to Boston Pizza. Join us for some more chat, not only about the stars, but quite a bit ends up being about things you heard tonight, things you're doing, and it's really a fun time to kind of coordinate. Don't forget members observing night tomorrow night. Scott's going to be there to open up, and 6 p.m. is the start time. Thank you very much. There's so many rules.